So good afternoon to everyone. Hope you are all doing well, right? So today I'm going to introduce the next topic in the course outline. So that is the correlation analysis. So correlation is another statistical technique which basically measures the relationship between two sets of data. Okay, two sets of data. So some of the important definition of correlations are given below. So correlation analysis deals with the association between two or more variables. If two or more quantities vary in sympathy, so that the movements in one tend to accompanied by the corresponding movements in the other, then they said to be correlated. Okay, so there are some definitions about correlation. I want you to read it, right? So what are the significance of the study of the correlation? So the study of the correlation is more of immense use practical life because of the following reasons. Okay, so you can study the relationship between the two quantitative variables. For example, there is a relationship between price and supply, income and expenditure, and so on. So with the help of the correlation analysis, we can measure in one figure of degree of relationship existing between the variables. Okay, so the income and the weight, right, pounds. The above data show the perfect positive relationship between the weight, that is, as income is increasing, the weight is increasing as the rate of change between the two variables in the same direction. Okay, so the income and the weight, all right, so it goes in the same direction. So I'll just show you the graph, all right? So then we can take it from there. Okay, so this scatter plot. So this is called a perfect linear correlation. Okay, so that's going in this direction, right? So you see the direction here. So it's perfect line, goes like this. So when this goes like this, we can say that there is a strong positive correlation, right? Because the correlation is or equal to 0.936. So remember that the value of the correlation is always lies between -1 to +1. Okay, so that is the limit. Like how I said, the probability is always lies between 0 to 1, and how the skewness is lies between -3 to +3. Similarly, the correlation coefficient always lies between -1 to +1. There is a range. So you can't give a correlation value negative 2 point something or 1.78 something like that. Okay, so the value must be limited to -1 to +1. Okay, so if it goes beyond that, then you are making some mistake somewhere, right? So you're wrong. So you need to look at the calculation or the how you did it in the, if it is in the software, then how you did it. So right, you have to look back to that procedure. So this is a strong positive correlation, and this is an example for the strong negative correlation. So when the curve, right, when you encircle it, the ellipse, when you encircle it, if it goes like this way, right, if it goes like this way, then we call that as positive correlation. Okay, and if it comes down like this, right, then if it comes down like this is called negative correlation. So the positive means this is the way, right, and the negative is comes down like this. So but both are very strong because they are very perfectly linear, right? And the values are very close. This is very close to +1, and this is very close to -1. So we need to interpret this as there is a strong positive correlation, and here we need to interpret that is there is a strong negative correlation. There is a positive correlation, right? But it's not that perfect linear how you saw in the previous graph, right? So though when you encircle it, so it is most of the points are coming under that encircle, right? But still, you see some of the points are scattered, right? So this we call this as this is the little bit weak, right? So it depends on the value you need to say, and this also here. So there is a negative correlation because when you encircle it, most of the points are covered in this line. Okay, there is a negative correlation, but it's not that perfect how you saw in there. So saw in the previous graph. Okay, there is not that all will fall in the same line, the linear, right? So we have to say this, there is a negative correlation, but not that strong. You do not need to prepare a scatter diagram to determine the degree of correlation between the two variables. we have a statistical procedure that allows us to compute the correlation coefficient directly from the data. However, a scatter diagram is helpful because it gives us a visual indication. So how you know when you look at the normality, right? And so when you plot when you superimpose the polygon, frequency polygon onto the histogram, right? So that gives you an idea that distribution is positively skewed, negatively skewed, and not skewed at all. The scatter diagram is an indication, right? The visual indication that gives you pictorially. It will tell you whether there is what kind of relationship between the two variables. So that is about the correlation coefficient. So next I will take you to an example, how to compute that. So everybody take down this formula. This is the formula to calculate the correlation coefficient. Okay, so write down this formula. So write down this formula given in the equation, right? So the Pearson, the correlation coefficient between x and y is given by R is the sample correlation coefficient. R, small r, is known as this sample correlation coefficient, and this is how you need to compute using this formula to compute the correlation coefficient. This is also known as Pearson correlation coefficient. Pearson, because Pearson is the person who invented this particular formula, this correlation coefficient, the measure. Okay, so some textbooks they use Pearson's correlation coefficient. So sum xy minus, so I just indicates the sample, right? With sample, you can plainly write sum xy. You can leave out that I part, the suffix I, you can leave it very well. That shows that you have to add all the samples. You multiply and then add the samples, right? So that's what it says actually. So you can very well leave the suffix. You can write n times sum xy minus sum x sum y, right? Sum x sum y, the brackets, and then the square root of n sum x square minus sum x all square times square root of n sum y square minus sum y all square. So you finish copying this formula? Okay, all right. So I'm just taking you to an exercise. So you can take that a 9.7.6 example. 9.7.6 example. So open an Excel sheet. I'll just show you this. You can calculate using, you have a calculator, y'all? Okay, I'll just give you this, the main part, right? Then you can plug it in and then you see what happens. So everybody open an Excel sheet. So this is my Excel. You're seeing it?
Yes, sir.
Okay, so what I want is, because I need to enter, I'm looking at the other computer.
Sir, I'm sorry.
So open an Excel sheet. You open an Excel sheet, and then you start typing these values. So I'm going to stop share for some time. So type these values in Excel sheet, everybody. So open a column for X and open a column for Y, okay? And type it in Excel sheet.
Okay, sir.
Okay, all right. Okay, so now I'm going to share that Excel sheet, right? So you have this, right? You all entered this. Okay, so next what do you want? You want x square, you want, right? So x square. And then I want, according to the formula I'm talking about. So what are the components you want from the formula? So you want x square, and then you want y square, and then you want xy, right? You want xy. So these are the things you want, isn't it? Can somebody, right? You wrote the formula, right, in your notebook? Just check, what are the components that you want. We want some x, some y, some x square, some y square, and then some x times y, isn't it? So these are the stuff we need, information.
Yes, sir.
Okay. So now I'm going to calculate the x square,
Yes,
right? So what is x square? X square is x multiplied by x, isn't it? So that is x square. So that you can give here is equals to, so what is that cell here? That cell, what cell is the first value? Is A2, isn't it? The cell is A2. So A2, right? So A2 means that for first number, multiply, so put star, multiply, and then you want A2 again. So A2 multiply by A2. So that will give you x square, isn't it? You got it?
Yes, sir.
Hello? Yeah, okay. So now what you need to do is you you select that cell, right? And put press Control and C, and then select all the other cells like this. Select all the other cells and put Control V. Control V. So you'll get square for everything. You're getting it? Okay. So similarly, you want the y square. So put equal to. Okay. So what is the first cell? Is B2. So B2 multiply B2. Okay. B2 multiply B2. So what are you getting? This cell. So put Control C and then select all the other cells and put Control V. So you'll get everything. Are you following, guys?
Yes, sir.
Okay, good. Okay, so next you want XY. So group is equals to, that is what? A2, right? So you want X times Y. So A2 multiply B2. So you'll get this. And then Control C and then select all the other cells. Then put Control V. Okay. So everybody able to get this information?
Yes, sir.
Okay. So now we want the sum. So you go to the X column, right? X column. So is equals to, put SUM, open the brackets, right? Open the bracket and select the whole thing, wherever you want the sum. So the whole thing, right? And then close the bracket here. So you'll get the sum, right? Similarly here, is equals to sum, open the brackets, okay, and select from here to here. And then click it somewhere, you'll get this sum. Similarly here, SUM, open the brackets, select all the cells, and then close the brackets. So this is equals to sum. With that. And this is equals to you're getting all the sum?
Yes, sir.
And you need n, and n is equals to 50. Okay, so now you take the sums, okay? You take all the sum because we need to do we can verify it later on with the SPSS. Okay, so take the sum. This is sum x, and this is sum y, and this is sum x square, and this is sum y square, and this is sum xy. Okay, so plug it into the formula and see what is the answer you're getting, the R value. And of course, n is equals to 15. Okay, n is equals to 15. The small sum and the sample size. So you have 15 as the sample size. Okay, so now you have all the information here. So just plug it into the formula and calculate what is the correlation coefficient and interpret the value. So you're getting 0.7885. You're getting this answer? The correlation coefficient as this?
Yes, sir, I got that.
Okay, good. How about the others? So you're doing it manually or no? You can do it in the way I'm doing it, but now you can do it manually, work it out with a calculator.
Hi, sir.
Hi, yes.
Can you use I'm not sure if it's the correct way, but can you use the correlation formula from Excel and get the same answer?
Yeah, you will get it. You will get it, yes. If you have the data analysis
Is it
pack,
just equal?
yeah, just and then select that area, XY, select XY, and then
Yeah,
you correlate, yeah, and then select the data alone,
yeah.
right? And then you will get it, yes. I'm just showing, how the formula works. Then in the same thing, when you do it in SPSS, you can get it in one step. You don't need to hustle and bustle. Okay, I just want to show the theory as well as the practical thing, right? Okay, so what does it say? Because it's a negative 0.7885. So there is a strong. You can use strong because it's once it is pass 0.75 to 1, you can use the word strong. So there is a strong negative correlation between age and the weight, right, of children, right? That's what it's showing. There's a negative correlation. Okay, so that is about the correlation part. Yeah, so you can just write the interpretation as 6 months to 15 years is the following data on X. And the liver volume, right? This is the liver volume per unit of body weight. Okay, so that means, so when the children grows, right, as the age increases, so the liver volume per unit of the body weight is decreases. Okay, so that's what it means. So when the age increases, the liver volume per unit of body weight is decreases. So age is independent here because the child's age, is independent, but the liver weight, right, the per unit, the liver volume per unit of body weight is the dependent variable y. So x increases, the y decreases. Okay, so that's why there is a negative correlation between these two. Okay, so this is about the correlation coefficient, right? So next I'm going to take the regression equation. Okay. So the regression analysis, it's a modeling. It is a modeling technique. So we'll see different regressions here. Okay, so the regression analysis is a modeling technique. It's a mathematical modeling, right? So you have the setup called independent variables and the dependent variables. So right now we saw an example. The age is the independent variable, where that liver volume on a per unit weight body weight is the dependent variable. Okay. So as a researcher, you have to identify what is your dependent variable and what is your independent variables. Okay. So the regression equation is a predictive technique, right? So which help you to predict the dependent variable with the help of some independent variables, some covariates, right? Some independent variables. So like if you want to predict what is the population into 2025 Guyana's population, right? So there, you have the past years. The year is the independent variable, and the population is the dependent variable. Okay, so you're predicting the population in the year 2025. Okay, so that's why the census alone they do it actually for every 5 years or 10 years, right? So, but in between we don't know what could be the population. So that's where the regression analysis is playing a big role in terms of predicting the gaps, right? So we call that as interpolation, right? Interpolation means, so you have values. So see, for example, the last was 2011. The next census will be next year, 2021. But if the government wants to do some project, right, and they wanted to know what could be the population size in certain area, so what they do is, they will take the past data and they uniformly divide it, right, and then accordingly they will say it won't be perfect 100%, but it will somewhere be there. It will be an approximated value. So with the help of that, you can do this analysis. So if you go into some of the websites like UNICEF, right? UNICEF. So they want to they look at the growth rate, right? Because they wanted to implement any program on the child care, right? So they wanted to know what is the population of the children in this particular country. Okay, so they can't go by with the census, because the census is always of certain time period. If they wanted to implement something in between that, so then you have to use the predictive technique now to interpolate the values, right? So for that, the regression is playing a very, very important role in terms of filling up those gaps, to interpolate the values which are missing. Okay? So in that regard, it's a very good technique. So in terms of predicting the dependent variable. So there are some of the mathematical equations, you have, so the curve fitting and all that. Okay, so modeling can be classified into two main areas. So one is the mathematical modeling, and the other one is the probabilistic modeling. So the mathematical modeling is something like you would have come across the linear equation, quadratic equation, and so on. Okay, so there, what happens, you will get a definite value for that. So when you solve the equation, you will get one answer for a linear equation for x value, and if it is a quadratic equation, so you will get a minimum of two roots. You will get two values, two roots you will get, right? So that is a definite answer for that question. Okay, but probabilistic modeling is all chance. It's based on chance, right? So because there are a lot of random components are involved. So the same example of the population, the Guyana population in 2025, you are predicting now with the data based on the past data, right? You are predicting what could be the population in 2025, right? So, but you have to use the word. You need to be careful in how you are stating that prediction. So you have to be careful that if the same trend continues, in 2025, this would be the Guyana approximately. We could expect that this is the population of Guyana. But in between, many things can happen, right? So there will be a flood, or could wash out, like the pandemic that we are seeing now. At least we don't have that much problem in Guyana, right? The number of deaths is 151. So this COVID is totally a random component, right? So which is nobody expected, and no precedents before this, and it's a severe thing. It created havoc, right? In US population, and in Asia, in India, China, all over these places. It's created a big problem, devastating. And also in the economy also where. So there is a tremendous reduction in the population, but on the other hand, you can see that there's a lot of the babies are also born, isn't it, during this period. The lockdown, they expected more pregnancies and more deliveries. So one side we are losing the population, the other side we are gaining it. So these phenomena need to be incorporated into the model, probabilistic model. So that is why see all this the predictive models, we have to consider some of the random components. See, and also you see a lot of Haitians some people are immigrating also. Some Guyanese, they're coming back, and they become immigrants. And you also have population from Venezuela, right? And also you see some Brazilians coming in, and then you see some Haitians are coming in. Okay, so all these components are attributing, right, in terms of the predictive model. So just the year alone, the year alone cannot be independent variable here, right? So you need to consider all these aspects in terms of predicting the population. Okay, so there are a lot of random components are involved. So that's why it's called a probabilistic, because there is a lot of random components are influencing this model. Okay, whereas in mathematical it is not like that. It's just solving the equation. Okay, so you understand what is the difference between mathematical modeling and probabilistic modeling. So you are all environmental people, right? So when you put paddy seed, what will you get? You'll get paddy, isn't it? After some time, when you plant a sugarcane, after some time you will get a sugarcane, right? So if you plant a mango tree, after some time it will bear fruits, mango fruits, you would expect. So these are all called the deterministic. So they're definitely it's going to happen, okay, unless if there is some flooding or the plant die or anything like that. Otherwise, it will grow, and it will give you what you were expecting, isn't it? So that kind of things will be called definitive models, or mathematical models will say that, but there is a definite answer for that. Okay, whereas in probabilistic, we add attached probability, and we also look into a lot of random components which are influencing this model. Okay? Some are controllable and some are uncontrollable. Like COVID, it's totally uncontrollable, but which is creating a big impact in the population. Right? So these are some of the mathematicals and the probabilistic models. Of course, we have seen the binomial distribution, Poisson, normal. We didn't see it, but the other models we saw. And then this is the straight equation, and this is, we call it this parabola or the quadratic equation, and this is the power equation, okay, and this is inverse function and so on. Okay, so this is some of the different examples for mathematical models which is solvable, and you'll get a definite answer for this. Okay, whereas here this is totally probabilistic. It's a lot of random component are involved in this. It's not straightforward sometimes. Okay, so now I'm going to take you to the regression model. So the regression line y on x. So that means you have the data on x and y. Okay, and you're predicting a model y on x. Y is the dependent variable, and with the help of the x, you are predicting the y. Okay. Yeah. Okay. So take this formula. These two formulas, equations number 934. So these two are called regression coefficients, okay? And the line y is equals to a plus bx. Just like your linear equation, you have this model here. So the line is a plus bx. So you calculate the value of b and a, and you plug it into the model. So that will become your regression equation, the predictive model. So you copy the equations. So the a and b are called the regression coefficients. They are called the regression coefficients. Okay. So once you finish 9.3.5 and 9.3.6, you calculated. So use that for the same problem that we worked just now. That the child's age and the liver unit and the liver volume, right? The example. So just plug it in, those values. You already have what is n, what is some xy, and some x, some y, and all that, right? So just plug it in these values into those values into the formula, right? And get the line y is equals to a plus bx. So a will be what you're getting when you solve a 9.3.6, that is your a value, and 9.3.5 the b value. Just plug it in those values and you see the equation there. Okay, so do that. Are you guys getting it?
Yes, sir.
Okay, so what does it mean? What does it mean? So when the age increases, right? So what does it mean that when the age increases, you have to interpret the regression coefficients, right? So this is a model. You are predicting the model, right? So the y is the volume of the liver, right? The volume of the liver per unit weight, body weight. So what does it mean? So when x increases, right? When the age is increases by 1 month, right? So 1 month, the weight of the child, the liver volume, is decreased by 1.5762 times. In fact, 1.6 times negative. That right is decreased by 1.6 times. So that is the meaning of this. Yeah. So when the age of the child is increased by 1 month, right? Then the liver volume is decreased by, because I'm using the word decrease because it's reducing, so decreased by 1.6 times. So this is constant, right? This value is constant. So what is the increasing or decreasing happening by this coefficient here? Because this is the coefficient, regression coefficient is multiplied by the independent variable. Okay, so whatever the alterations that you want to make with the independent variable, right? Whatever the alterations you want to make, so that will affect directly here, right? Nothing will happen into this value, but this value will be affect. And because of the negative sign there, so I'm using the word in decrease. Okay, so if there is a plus sign here, then I would have used the word increased. Okay, so the decreasing or increasing depends on the sign of this coefficient here, the b coefficient, right? So if it is positive, then it is increased. If it is negative, then it will be decreased, right? So that's the main criteria that you have to apply here. Did you understand the interpretation I've given for the regression coefficients here in the chat?
Yes, sir.
So this is about this is for the linear regression model, okay, the correlation in the linear regression model, and then you have another thing is called coefficient of determination. Okay, so that is equals to r square. So what is the correlation coefficient got? Negative r square is equals to negative 0.7885. So what is the value you're getting? 0.6217. 62% of the variation volume of liver, right? Volume of liver is caused or by the variation in the age. Okay. So that means now whatever the alteration that you wanted to make in the age is an independent variable as a child grows. Okay. So the variation in the volume of liver, right? The volume of liver is caused. The age is contributing 62%, right? The age in the sense when the child grows. When the child grows, so the variation in the volume of liver is caused by the age, right? 62% is contributed by the age, okay? There is another 38% of variation is there, right? Which is unaccounted for in the sense that, you know, they did not capture those values. They did not observe those components, the remaining 38% of components, which could contribute to the changes in the volume of liver in a child's development, right? So the age causes contributes 62%, right? And there is a remaining 38%, which is unaccounted for, right? So we need to observe that as a researcher. They have to.
Sir, is this the only formula we could use? Is there any other formula?
Which one, for B and A?
Yes.
Yeah, this is B. Yeah, this is formula. Yes.
No other formula.
No other formula. Yeah. Why you're saying that? No, you can have a. No, I don't say there is no other formula. You can use the normal equations. You know, you know the normal equations, right? This is an alternative formula, right? Which is much easier.
Okay.
It is much easier to calculate. So this we call the normal equations. So you have these two equations, 9.3.2 and 9.3.3. Okay, and you have all the other values, right? So when you plug it in those values, like some y and some xy and some you know n is 15 and b summation xi, right? So these two equations will form into these two like this, right? When you plug it in those values, you will get an equation like this. This is another example, but I know, so I'm talking about the present example that we are dealing with. So when you plug it in those values, you will get a two equation like this, right? And then you can solve for A and B simultaneously. So this is one way of doing it.